So without further ado, welcome to this joint webinar of Factor House and Ververica. My name is Ben Gamble. I'm the field CTO here at Ververica, the original creators of Apache Flink. And today it is myself and Jae-Hoon Kim, developer experience engineer at Factor House. Jae-Hoon, would you like to give yourself a brief intro?
Hi, hello. Yeah, my name is Jae-Hyun, and I'm a developer experience engineer at Factor House. Yeah, a former software engineer. I'm just quite, involved in data engineering, data streaming for a number of years, and I'm quite happy to present something today. Thank you.
Wonderful. Factor House are the creators of the wonderful Kafka UI KPow and increasingly more detailed stuff around UIs and governance tools for Flink and general streaming technology in overall. Today, what we're going to do is we're going to have two kind of presentations about how data lineage is becoming increasingly important. To start with how to do it on a very practical nuts and bolts level, and then kind of what happens next once you've got it and why you need it. So that's kind of our agenda for today. But as previously mentioned, we're really happy to answer questions as we go along. So please ask them. We might answer them at the end, but we do promise to answer your questions. They can be about almost anything. Today, I'm not near my ducks. Otherwise, I would normally pick up a duck and show you one on camera, but not today. So without further ado, Jay is going to go first and show us a bit about how to make Lineage happen with OpenLineage Factor House.
All right, thank you. Let me share my screen.
While Jay's getting set up, Madhu, I will happily talk about your question at the end. This is something I do work on quite regularly.
So let me just reshare, just in case. So do you see my screen? So yes, so let me get started. So yeah, as you mentioned that today I'm going to talk about building an end-to-end data lineage using Kafka, Flink, and Spark. And the focus is more on the streaming context. So let's get started. So for startup, so what is the data lineage, by the way? It is actually the journey of your data. So it shows where your data comes from, what kind of transformations are made on it, and where it ends up. So data lineage can be important. So let's say you have a dashboard, and then you see there's some kind of discrepancy. Then with the lineage, you can quickly go back to the source of the data and then quickly debug what's going wrong. And also, if you want to change something on one particular step, and then you can quickly identify what kind of impact it might have in your downstream workloads. And also, it's important for compliance and audit. And most of all, it can build trust and reliability of your data product. So when it comes to implementing OpenLineage, we are going to use, data lineage, we are going to use OpenLineage, and then it's an open standard for capturing lineage metadata from jobs in execution. So think about this way. So data lineage, so you want to extract some data from your transactional database and then do some transformation and load it into your data warehouse. So this whole ETL can be considered as a job, and then most likely you schedule it every day. So the whole ETL process is a job, and then actual run. So today, yesterday, so this actual execution can be considered as a run. And most also in each of the run, it has its own input and output data set. And then it can be quite important because over time data may change. So these kind of job, run, and data set are main entities of that OpenLineage. So to understand, to make it easy to understand, think about daily ETL jobs, then it will be easier to understand. And OpenLineage supports, actually it integrates with popular data tools. So Airflow, DBT, Great Expectations, and also Flink, Spark, and Hive and Trino. And we'll also talk about Marquis. So it's an interesting tool. So it's a kind of reference implementation of OpenLineage, and it provides the UI to show your whole data lineage graph. And note that although Kafka is quite an important technology, but it is not an official integration as yet. But still, we are able to set up kind of lineage using Kafka as well. We can talk about this one later. And then, so here, today's demo, the main focus is in streaming environment, but still the lineage is more popular, it's implemented in a more widely in a batch environment. But before we talk about the streaming context, so we need to think about some of the differences which can be considered as some challenges. So in batch environments, all data sets are bounded. So we know the start and end of the data. But on the other hand, in streaming context, think about Kafka stream is just data is ingested every second, and then there's no bound. So the first challenge is that data itself is unbounded. And also the life cycle for batch is finite and scheduled. But on the other hand, in streaming context, the job is continuous. So in the batch job, there can be multiple runs, but on the other hand, in streaming context, we wouldn't have many runs. So even if there are some differences and challenges, but if we are able to integrate in the whole lineage, in the entire enterprise workloads, then we can have more, that reliable and observable system, and then it can cover the whole enterprise workload. So it can be quite important to add to instrument lineage in streaming technologies. So the first one that we are talking about is Kafka. So as mentioned, that Kafka is not an official integration, but OpenLineage provides its own client. So we can make use of it. So today, in this demo, we have two. So we are going to talk, implement Lineage using Kafka Connect, which is a data integration tool for Kafka. But we are going to use custom single message transform instead of, and then the reason is that we are going to use two Kafka connectors, and then we wouldn't like to change the individual source of the individual connectors. But if we are able, if we use the single message transform, then we can build that function at once and then apply both the connectors. So normally single message transform is used to change the message of the individual data, but we are not going to change data, but we just hook some connector lifecycle events and then create OpenLineage metadata and then transport it. So what we are going to capture is that the running and fail and then complete status of Kafka connectors, and then these states are also mapped into OpenLineage job connectors. So when we first deploy a connector and each state can turn into running, but if there's something wrong, then the state turns into fail, or if we just delete it, then the state will be turned into complete. And then more on that, if we just make a lineage between job only, then it wouldn't be that useful. So the more important important part is that what kind of transformation is made. So for that, we need to add some dataset information. So depending on this situation, dataset can be either input or output dataset. So for that, we are going to rely on the schema from the schema registry. So each of the connector assume that data is in error format, and then their schemas are registered in schema registry. So what it does is that when we first send the message of the OpenLineage metadata, then we read each own relevant schema and then extract some fields details and then create input or output data set depending on the context. So we just send it together so that in the whole lineage graph, we are able to see the job and run as well as the relevant data set. And then another one we need to think about is the consistent namespacing. So we'll be using different technologies and to build the whole data lineage graph, especially the data set namespacing is very important. So we'll come back to this one later. So, but because it's quite an important thing, so I just mentioned this one at an early stage. So this one is the whole lineage graph in our demo application. So we can see that two jobs, Kafka jobs created in our demo application. So first one is that the source connector. And what it does is that it just generates fake records and then push those records in the orders table. And then the second connector is S3 sync connector. So it reads records from the orders topic and ingest into an object storage directly. So with these two jobs are linked, and the first job generated output dataset, and the second connector has two datasets. One is input dataset and output dataset. So these are our data lineage in using Kafka connectors. So, and then the second one that we have in our demo application is Apache Flink. So OpenLineage, Flink is an official integration, and OpenLineage handles Flink 1 and Flink 2 differently. So in Flink 1, we need to update Flink execution environment by adding OpenLineage Flink job listener. So the reason is that using this listener, we are able to extract all the lineage metadata and make exportation into the relevant backend service. So it requires, because we are using the job listener and then change execution environment, then it requires to change the code. But although we have to change the code, but it provides a simple and out-of-box integration. But when I actually implement this solution, but I still found some issues. That one is that, let's say, when we deploy a Flink job, then the job is created in OpenLineage, and then the status is running, it's good. But when I cancel it, I expect that the state should transit into abort or complete, but it's not the case. So this is a bit of a limitation. So to fix that, I have to manually transit the state using communicating with the API on my own. And then the second one, we have the second Flink application using table API. So still, we may be able to use the job listener based method, but when I tried it, yeah, I'm able to set up the lineage using jobs only, but data sets are not extracted. So it's not possible to make a lineage because without linked data set, jobs cannot be linked in OpenLineage. So using table API, it's not supported, but still it's not the end of the story because OpenLineage provides its own client, so we are able to orchestrate all of the lineage lifecycle on our own code using OpenLineage Java client. So it provides a complete lifecycle. It provides complete lifecycle tracking, but it requires more explicit code. And let me just mention another limitation in OpenLineage, a Flink 1 integrated. That one is that because the way how job listener is integrated, Flink SQL is not also supported, and also all the Flink jobs should run in an application cluster. So these are additional limitations. But on the other hand, that kind of limitation is gone away in Flink 2. So over the longer term, yeah, there will be more nicer integration we can expect. So in this lineage graph, so we have two Flink jobs. So the first one is supplier stat. So it reads data from orders topic and then provides some kind of supplier statistics. So it's kind of tumbling window by supplier and then calculate total price and count. So we have the same original data set, but the output data set of this job is different. So it's because this Flink job performs some transformation. So this one is that integrated with the job listener-based method. And then we have the second Flink application. It uses table API, but what it does is quite simple. It just reads from the orders topic and then ingest into an iceberg table in an object storage. So actually, it looks like the same, the field are same in the iceberg integration, but when we actually see that the lineage details of the data set, then you will be able to see that their column types are a bit of different because, that the way how we handle a particular column in Kafka is different from in iceberg. So you will see a bit of differences. So these two applications are Flink integration examples. And then we have the last example using Apache Spark. So streaming context is not the only story because there are lots of history or batch type analysis in enterprise workloads. So Spark is quite a popular data processing engine. So yeah, OpenLineage also supports Spark, and we can use that OpenLineage Java agent, adding this one into Spark extra listeners. Then once we do so, then it auto detects input and output from a query plan. So it's a lot easier, and I believe that the Flink 2 integration with OpenLineage will be quite similar to this pattern. And one thing to have in mind that, let's say in a Spark application, there are multiple actions. Each of actions are translated into a single OpenLineage job. So even there's a one Spark application, but there can be multiple jobs. And then earlier I mentioned that namespace alignment is quite important to make the whole data lineage across multiple technologies. So the whole, in this demo application, we are using Hive meta store, Hive catalog. So iceberg tables are created using Hive meta store. So then we have two level of namespacing option in terms of data set. So the first one is the logical plan, and then in that case, the namespace is likely to be more natural to be Hive meta store URL. But on the other hand, we can have a physical namespacing option, which is the actual object storage location. So initially, I tried with the logical plan so that the output data set of the Flink job to be the Hive meta store URL. But Spark failed to identify the data set as its input. So I had to change the dataset namespace into the physical namespace, which is S3 object location. Then only after I made the change, Spark was able to recognize the output data set of Flink job as its input data set. So it allows this change enables to make a link between Flink and Spark. And as mentioned, that multiple Spark, each of the Spark actions can be is translated into individual OpenLineage jobs. So this Spark application basically has two actions. One is create an isolate table. If it doesn't exist, that's one action. So we see this one. And then the second one is the main transformation. And then it links to all the way to the final output data set. So by using this one, we have the whole lineage data graph, including multiple data technologies using Kafka, Flink, and then Spark. And yeah, I will be share the link of our demo lab location, but this is not just only for this is not just working for this demo, for this presentation, but we can actually deploy, test the demo application on your local machine using our demo environment. Then we have all of the jobs created by for this demo. So the first three are jobs created by these are created by Kafka, Flink, and then Spark. So when we click this one, then we are able to see the whole data lineage graph. And then Marquis provides some extra details about the jobs. So all of the jobs share the same namespace, and then data set. We can have a look at some Kafka data. So Kafka data set, the namespace is natural to be the Kafka bootstrap address. And then S3 dev bucket. This one is the second Kafka connector. And then this one is for that iceberg. So as I mentioned that I had to use this physical namespace. I mean the physical location of the data to link between Flink and Spark. So yeah. So these are all the demo that I prepared today. So here key takeaways is that when it comes to implementing data lineage, then we need to think about, choose the right pattern. So we need to balance between simplicity and reliability. So for the first Flink application as an example, it's quite easy because there's a official integration by manipulating job listener, but it has some kind of limitations. So for example, state transition is not complete. In that case, we may consider, using our own, orchestration using OpenLineage client. So, but it's up to the developers. And then namespace, aligning namespaces is really important, especially in the cross-tech environment. So the next step is going to be, you can explore the data lineage step. The link will be provided at the end of the slide. And then if you're interested in, then you can instrument, select just the one critical pipeline and then try to implement data lineage first. So and then this is the end of the presentation. And then, while we are waiting for some questions, then here, if you are interested in, you can come to our Hackhouse community Slack channel. And then if you just leave some questions and add a comment, then we can just, we can talk about further about data lineage or other data streaming in general. And then if you want to try this demo application on your own, we have a GitHub repository, Hackhouse local. So you can implement everything on your own laptop or computer, depending on your machine. So that's it for me. Yeah, thank you so much.
Brilliant. Thank you very much, Jay. So we do actually have some questions, which have been really cool. So some of which I've answered along the way, First thing I'll state is yes, we do all like Debugging and we use it a lot across many of our projects. The whole of Flink CDC is Debugging based. Anchor, your question about links will be shared in a minute. So any links to anything we do will be shared either as we go along or at the end. Don't worry, they're coming. So another question was about column level lineage in streaming. So I'm going to talk a bit about how we do column level lineage a bit differently in Ververica, but in Flink 2.0, this is something coming along. Jay gave a reasonably good explanation of how they do column level lineage across some of their tech. We start to get into like what OpenLineage really is a bit, and this comes to Mark's question. So it's about how do we map run concepts to streaming. I'll tell you how I see it, which is that every time you run a Flink job, that or scale a Flink job or redeploy a Flink job, that is a separate run. Jay went through pretty clearly how they view it as well, which is somewhat similar, but not quite. By the way, ask repeat questions if you want clarification. The open questions, these go directly to Jay. For integrating into KSQL DB, bold statement, Alex, bold statement in this day and age with OpenLineage. I wonder if we can use the logic in your SMT in a UDF. Have you ever tried this?
Yeah, to be honest, I haven't tested Lineage using KSQL DB, and then probably it's not. I mean, even Kafka itself is not integrated officially, and then, but when it comes to Kafka Connect, we have some. I mean, I just added the SMT as a plugin, and then we have to check if there's just some kind of plugin like stuff that we can configure in KSQLDB, but I cannot answer this one straight away. So still, yeah, data lineage using Kafka is not that widely used. So there's a lot of unknowns at the moment. Yeah.
Okay, cool. So is that SMT actually open source? That's another question from Theo.
Yeah, so we built it, and then it's included in our Factors local, so it's available. So yeah, it's not. I have to remind that it's not a general purpose SMT. So it is tailored for our demo environment, and then mainly targets three connectors. One is that Amazon MSK data generator, which generates some fake data using Kafka Connect. And then Confluent S3 sync connector, and then Iceberg sync connector. So we target these three connectors, but of course it can be extended into other connectors as well. But yeah, it's up to the developers, the users who use that one. And also another one that I need to mention is that so many people are using Division connector, right? So these days, Division implement its own OpenLineage on its own, so it can be quite easy to implement if you use Division connector. Yeah.
Okay, brilliant. And Anchor, about Confluent platform users. This is where we go into the territories of what Confluent has and hasn't done. As Confluent platform is a closed source piece of technology, two, something neither of us have control over. And as a former user, it was a very nice Kafka platform. I don't know is the short answer. It used to be relatively easy to put things like custom SMTs into connectors there, but I'm at least two versions out when it comes to Confluent platform. Jay, do you have any more knowledge about doing this on Confluent platform?
I think that, okay, in the Factors local, the Kafka Connect Docker image, we use Confluent image, Docker image. So I'm sure that you can implement that
Yeah.
one on your Confluent platform as well.
So I will say this about Confluent's Flink offering. Now, the cloud one is entirely different. Who knows what they've done there? They've done a lot of work to try and make it very serverless. So I can't really speak to that. For the platform, you have more options. You can run your own data stream jobs, if I remember rightly. So in theory, you can implement the source code. I do not know what version of Flink they map to. Therefore, your mileage will vary based on what your Confluent folks can do.
Yeah, so when it comes to Confluent provided Flink, so but I think it's my understanding they only provide at the moment Flink SQL based one. So
That's the main thing. On-prem, it's a bit different. I know it is different
okay.
because a friend of mine is the product manager for it. The world is very small in Flink, but it's also just a proprietary product. I'll talk about my proprietary product in a minute, and I think you can do it if you can get to the Java land. However, there are lockdowns. Your mileage will vary, and of course, apologies, we can't really go much deeper than that. If you have follow-up questions, please ask, because that's really kind of something we're really keen to do. So, without further ado, I will talk more. And this is something I am well known for doing. Right, 1 second while I make sure I actually have my presentation open. Okay, so here we go. Just listen to center view. And can you all still hear me? Yes. Good. So share. Brilliant. So thank you for listening so far. This is going to be my presentation around data lineage in data streaming for fintech and more. So I'm going to run through a bunch of the fintech examples of this and why this matters. Because in fintech, it often comes up more often, but as everyone these days, regardless of who you are, effectively is a fintech and an e-commerce player, a lot of the rules apply across the board. So without further ado, let's scare people. Now, this is a bold statement, and I've said this a few times in the last, year or so, which is about half of us in all digital fields will fail in about the next 3 years. This is kind of the half-life of all of our companies. And this is accelerating due to some of the technological and legal framework changes going on around us. And these are quite serious. And before I kind of go too deep, a lot of you might not know who Ververica is, and this is the whistle stop tour. So we've been around for a while. We created Apache Flink long ago under the name Data Artisans and changed our name a little while ago to make it extra confusing. We've been around for a while. We do cool stuff in loads of fields. Loads of people like us. It's fun. But the real cool thing here is that we support users of Flink across the globe in some of the coolest places and challenging things you can imagine. But what it really is, and this is really Flink as well, is the answer between right and right now. Because the problem without this stuff is that it's great to have the right answer. It's not great if you have it too late, and it's not great if you got an answer when it was wrong. And this is where kind of like the origins of Flink came from, which was the ability to do bigger, faster data. There was a project called Stratosphere way back in the 2010s where it was Hadoop is slow, which we all remember. So we wanted to say, what happens if we do it bigger and faster? How do we make it streaming first? And like a lot of databases now are also streaming first, but this is where Flink came from. And over time it has evolved and we've evolved with it. And these days, like it comes down to requiring a unified streaming data platform. So we built something called Vera, which is what we do on top of Flink to make it a bit more cohesive, to connect all the cool stuff on the left and do all the cool stuff on the right. Don't worry, I'm not going to go too much detail into this. I would love to follow up if you're interested though. So what this brings, and this is what's important here, because the reason we do this is why. If we could do this with cans and string, we would do that and it would work nicely. If it still worked in Excel, we all know that our colleagues would still be doing this in Excel. For good reasons it doesn't, and everyone is grateful, though more is done in Excel than we want to admit. So particularly Flink and Ververica, it's about real-time decisions across many different industries. It's about data in motion to meet diverse needs. It's also data in rest. So this Flink is not just a stream processing engine. It's also a batch processing engine. It's more similar to Spark than people realize. There is no strict Kafka dependency at all, however much other people say. And at least a number of our users mostly use it to read and write to mainframes. And the idea really is to be that one platform to handle a lot of these analytical and operational use cases with very strong exactly on semantics. And increasingly, that means AI. There's a really cool post recently on LinkedIn about how OpenAI are doing more and more of their own work inside Flink. And I know other the AI vendors do as well. So Flink is not just being used by people using AI, but it is powering the AI you are using. So let's go back to why things are going to break for everybody. So the world's changed fast. The 90s was the dot-com era. It went boom, and then it went away. 2000s was Web 2.0. If you remember, like the birth of social media and everything having single sign-on and all that stuff. And then in the 2010s, it was smartphones. It took a few years for the App Store to appear, and it really kind of like became everyone needed an app, if you remember. So it went from everyone just needing a website and their own IDP to we'll sign on with Google to then suddenly everyone needs a smartphone app to the 2020s and the pandemic, which completely changed the world. And now it's AI. Like 5 years later, it's no longer like how does everything work remotely? It's no longer the era of the online conference. No, it's now AI does everything. And what are we talking about today? We're exploring an AI story through banking. We're thinking about a mix of brick and mortar banking. It could be brick and mortar stores, online banking, very similar to e-commerce, and mobile banking, anything with a mobile app. And the first thing you have to remember is nearly all businesses have been around for longer than you think, particularly the big ones. And even the ones like the new wave of web startups, think the Airbnbs, are over 10 years old now. And it means that like global market growth is something we want to meet. You got to meet these increasingly annoying cultural expectations in different parts, and you've got to expand your infrastructure to handle this ridiculous scale. And anyone who's still here survived the pandemic, which means that a lot of changes have to be made very quickly in most cases to kind of both stay alive and beat the competition that was spawned during that time. And now everyone's trying to evolve with AI, but there are challenges. Let's talk about a few of those. The first one is digital native users, right? Everything's online, everything has more attack vectors. Our kids are pretty much growing up with the ability to have all data in their hands. The mobile first user experience means low bandwidth, low security devices are where people make their decisions, including how to pay people. That can be a bit scary. And loyalty is not guaranteed. Even your bank is an app, which means for a lot of people, changing banks is as easy as downloading a new app from the App Store. With faster sign-on rules, it gets a bit worrying. It is very much keep up or get left behind. Let's talk about the absolute fundamentals here, because I've just kind of glossed over the high level right now. The real challenge here is experiences people have meeting their expectations. Because loyalty is fickle. In most places these days, you're one among many, and user experience is nearly always a differentiator. And particularly if you're not real time, if you're not secure, that is a problem. Because the expectation is that fast user experience, that personalized user experience, and that relevant user experience. Now, this gets even more complicated as you go along, because we're now paying for the cost of past successes, which meant that, the technology, because as the technology changed, it's been expensive to maintain. Products have changed because of it's not just things you're selling off a shelf. It's also the fact that your now lovely shiny web portal, which did everything once, is no longer good enough. People have changed. So this is the real critical one. It's not just the people, it's the legislation around them. There's something called BCBS 239. Yes, I've had to learn Basel regulations again. These basically state that your banks now have to follow increasing numbers of rules about where their data comes from, how they make decisions. Think about how GDPR changed the world and then how that was used as model legislation around everywhere. This means that it's no longer good enough just to have the data and the answers, but you've got to know how you got them. You've got to have the governance and the knowledge and the provenance of that data ready to go if challenged. And ideally, to do it ahead of time. This is about meeting those challenges. Everyone assumes you've just got to go faster. That's the kind of like default board level answer you get. Go faster, use more AI, go, go, go. And the general rule here, particularly in engineering world, is smarter is always better than faster. You don't just need to AI generate a whole code base overnight. No, we can do better than that. Because like a big part of this is about leveraging what we already got. We can log everything users do with the right tools. We can store it, we can process it, we can clean it. You've seen a pipeline like that already today. Real-time data is where we can really start to leverage the changes, because it's all well and good to know that Jay has just bought a new car, but if I don't try and give him a car insurance offer in the first week, he's already got it. So it doesn't add up, right? And this is where we want to make decisions faster and make decisions now. because everyone talks about real time, but real time is a bit of a fuzzy word. What really matters is now, right? And AI and ML being a commodity means this. ML is when you own the model. AI is when they own the model. And what that means is you can start having your systems make decisions immediately. But here's the best bit about Lineage. Lineage provides governance because it means you know as a company what data went into that decision. It means every time you're challenged or, God forbid, you're sued, you can now say, no, we never let proprietary data get there because we can show what happened next. It also means that when you're trialing products and building safe products, you know what's happening. Back to Jay's point about trustworthiness here is you can't make something you trust without understanding it first, particularly when it comes to having money on the line. And this is where we come back to this kind of thing, right? Which is today data is reactive, not proactive. And this means you're waiting for things to happen. Lots of things can go wrong. The wrong/unreliable answer piece and the loss of customer trust comes from when you either have tried to go fast without looking at your guardrails, or you've made a decision based on data you didn't fully have control of. These things happen more often than not. Fines in the tens and hundreds of millions happen quite often in the EU these days. So it's no longer really something you can sort of chance. And particularly with AI, there's kind of four fundamental limits. Universal accessibility has sort of been solved now. That infinite knowledge, in theory, they have, but they're not very accurate, and their cost efficiency is a bit ropey at best now. And this is where we come down to the core axis of nearly all good user experience. And user experience is what people want. It doesn't matter if the user is a machine or the user is a human. It's all about trust and speed. So let's start with the idea of a blink of an eye. A blink of an eye is about 250 milliseconds. A quarter of a second and under, people tend not to notice too much. That's as fast as your decisions need to be made or your apps need to accept something for someone to feel really good about it. And that's for payments and things like that. But here's the big kicker. A breach of trust lasts forever and it doesn't go away, right? If you breach the trust of one customer, they're probably gone if they can get out. They'll definitely not trust you back. So this is where the churn comes in. When you get to transactions and customer service, this is even more relevant. If you remember the Canadian airline who tried to sell something that didn't exist via AI, good lineage and good governance would have stopped that getting into production. So let's talk about what this all adds up to. Trust and speed is the ability, comes from the kind of idea of getting things faster. You press a button, 100 micros, and you've done the button. Mobile internet on a good day, 100 milliseconds. That's a good day. London's a bit slow today. And then if your servers are taking a day plus to run through a mainframe loop, that is bad. You're never going to hit this kind of sweet spot of things, right? And this is where, when you do have slow data, you can start to know where it's coming from. Because if you're always hitting a piece of out-of-date data, Lineage will help you find it. If you remember the big revolution, which was open telemetry, Lineage is taking that back into the analytical domain rather than the operational domain and saying, can we understand our data rather than just understanding our errors? So what do we want from AI, right? Well, the big things we've always wanted from AI are enhanced customer service, robo-advisors, and the ability to sell stuff live, particularly if we're the business owner. And most of the time when we're building stuff, we're building it for a business, right? And how we get it is we have to act on up-to-date information. This is why you need pipelines that have things like Flink, things like Kafka, things like Spark in them. You need the strong guarantees to go with them. This is what kind of separates out the toy pipelines, which are often used behind the scenes to generate a report, which then someone uses, versus something you can put into production today and put humans into. Having strong guarantees means you know where the data is coming from. It means you don't fail the next SOC audit or the next GDPR audit. If someone does a subject access request in the UK, that means they want to know where your stuff came from and how you made a decision. Think about the right to be forgotten. Think about all those really good kind of privacy things coming up now. And if you can't guarantee it, the fines get astronomical. So think about particularly that new Online Safety Act. Now imagine you have to have lineage to prove that you did indeed prevent the wrong people from logging into your service. This stuff all matters. And the most important thing then is if it works, you've got to scale to meet demand. There's nothing worse than a successful product that brings you down because it didn't scale. Because tomorrow's decisions are fueled by real-time intelligence. And this is not just AI, but it goes across the board. Smarter, faster actions taken, better experiences, accuracy, and also this idea of always knowing why things happened. You don't want to take a bet that you pulled the right ID field. Let's say you're selling someone a concert ticket, right? Is it the ID of the conference, the idea of the seller, the ID of the buyer, or is it the ID of the venue? You don't actually know unless you have some way to tell. And if you've ever been through one of those DBT hell scripts where you have to trace through every single kind of statement and merge and join to work out what happened, because it turned out one of your analysts figured transpose was a really good operator to put in the middle of a pipeline. Yes, I have been there. It might have been mine. These things matter. And this is why having things like OpenTelemetry and others really kind of bring a lot of value to the thing. So let's talk a little bit about what we do. So we have our own kind of platform here, which hosts a version of Flink called Vera and allows you to have that real-time ingestion. We do support field level lineage out of the box. It isn't OpenLineage because we did this before OpenLineage was a thing. As is often the case, if you move first, the open source catches up to you and is different. But increasingly, we are supporting OpenLineage as well. As we are still a one-to-one runner of open source Flink, you can just attach it all. And we're supporting increasing numbers of people doing this stuff. Because this is what really kind of ends up happening. And like, I'm bringing up the AI kind of thing in the corner because more often than not, we're all going to be challenged to put our data into AI at some point. And this is a kind of resounding thing we've learned over the last 9 months working with a lot of the banks we work with, which is you end up needing to get thousands of data sources into one place, whether they're fresh or historic. And the only way to get accurate AI responses from anything is to have streaming data, right? It's that, and also have control over it. If you don't have a full understanding of where your data has come from and your AI makes a decision, you never know what's in your context. If you're suddenly leaking PII into your context windows because you didn't check where it came from, you don't have any way to guarantee that, you're into a place where you might not be able to forget that information. And having a unified data streaming platform, of course, needs some benefits. And, we run a bit faster, we run a bit cheaper, and we test available people. And the thing that everyone kind of worries about this kind of stuff is migrations. Now, this is really just about what it takes to migrate to something with Lineage, to something which is streaming. Because everyone says, oh no, I need more compute. I'm going to run out of servers. Oh no, it's going to take way too long. And we're going to lose revenue because we're going to turn things on and off to make it happen. We've all seen the 3-year migration on year 5, which is still unfinished. And that's kind of a big thing we believe here. And I believe very strongly about like the open source on, particularly when it comes to streaming, is you can modernize without compromising. Databases have CDC streams. You do not need to change them. You can pull the data out. We can do the same thing with a mainframe. We can pull that in, we can process it and go. We do not need to turn it off until we're done with it, right? We can even connect on-prem. There's no limitation to this stuff. None of this is specifically cloud only. And of course, that doesn't mean it's prevented from running in the cloud either, because we still need to bridge the various domains where they are. And this is when AI comes in. By having that real-time connectivity, by being able to move the data with the governance attached, with the lineage attached, you can now feed those AI pipelines along the way. And hopefully get rid of some mainframes. Please get rid of mainframes. They're really expensive. If you want to learn more about what I've just talked about, like this is a blog about real-time feature engineering on Ververica, using an example of an e-commerce shop. It does reference Lineage quite heavily. And we're in a week and a half or so. I think myself and Jayon will be in Barcelona talking about Flink and the future of real-time and AI at Flink Forward Barcelona this year. There's a QR code there, but if you, but I think we can send to everyone who actually signed up here a larger discount code because it's so close to the thing. We're doing that. We're offering a much larger discount. I believe it's 50% now on both training and the conference itself. I am hosting the deep dive training, where we're going to learn how to do everything from hybrid sources and backfilling in Apache Flink to running and training live machine learning models to hooking up your AI vendor of choice along the way. So thank you for listening to my part of this. We can ask any other questions you like, and we can always run back through them as well. So I'm going to click yes to your, I believe these are questions where you can hear us or not. There are still some of you here. You have stayed to the end. Thank you very much. I did say I would answer one question at the end. Someone asked a question around debugging the Flink table API contents. They have our app streaming data from Kafka is filtered into the table API objects, and they perform SQL and generate events based on SQL results. If the SQL join is not satisfied, how do you debug the application? This is like a classic thing. Start with Lineage really helps here. Like up front, this is like part of why I'll do answer this one at the end is if you have Lineage or your fields going through your SQL statement, you know where they came from at the end. This will tell you if your join is doing what you think it's doing. If your join is not firing, it could be many different things, as you've not told me what kind of join it is. It could be the fact that you're not sending watermarks. It could be simply that you're doing the wrong kind of join, or it could simply be that your data isn't there. Debugging like this sort of stuff works well. Selfishly and contractually, I must say that we have a really good SQL editor, which will tell you what is wrong live. But the key thing to note here is that you kind of have to run it to see what's going on here. Like ideally locally, even if you're just running it in PyFlink or in Java Flink, run it as a SQL statement inside a table API job and then run that. That is my kind of starting point. If you'd like to ask more questions, join either the Flink Slack or the Back to House Slack and ping us. We'll see what we can do to help you. Oh, there's more questions. Yes, people are still here. Wonderful. So in addition, if anyone wants to kind of deep dive into any of this, we're going to try, for anyone who actually stayed to the end, we will try and host an online workshop where we allow you to kind of go a bit deeper into this and try it with us. We'll do that probably after Flink Forward, simply due to the incredible amount of work it takes to get one of these conferences off the ground. But that will be done in the next few weeks, and we'll send out an invite to everyone who physically attended. Also, Sarah, if you have any questions, please ask. The chat was disabled, but we do have the Q&A. It means we can screen them before people see them. Well, wonderful. It is very quiet. If there's no other questions, please, we'll give you another minute or two. We have finished pretty much on time, which is almost unheard of. So hopefully you've enjoyed everything you've heard today. Hopefully you've learned something. And hopefully we'll all see you at Flink Forward or at the next one of these or at the workshop we'll run based on this later. Without further ado, I'm going to give you a whole couple of minutes back. I think we can do that, can't we, Jay?
All right. Yeah, that's good. Yeah.
Brilliant. Well, any last minute questions? Now's the time. And okay, I think that's everyone. Mandu said we need kind of more information before we can really help you there. Ask on the Flink Slack and tag me. I'll see what I can do.